so we've got part 2. Let's just make that. We've got the diagram shows how energy is lost from a house. So you got 5 areas there. You've got the roof, the walls, the draft from underneath the door. You've got the floors and the windows. So just of interest here is you can have draft excluders. You can get cavity wall insulation. You get loft insulation. You can get double glazing. And you can also get heated floors there. To reduce that effect. I just wanted to put that out there. So, calculate percentage energy lost through the roof. Well, you just add all these up, and you know that the percentage is always in 100. Hopefully you know that. So 100 minus 78 is going to be 22. Stick method of reducing energy lost through the roof. That could have been any one of those. So loft insulation, but if it's said through the walls, cavity wall, through the windows, double glazing. Okay, everything that I mentioned. Explain how this method reduces heat loss through the roof. Kind of like the 6 marker we just did in the previous video, the fiberglass is going to trap pockets of warm air that rises, and that's going to prevent the heat loss via convection. Okay, and we'll go on to the table. I shouldn't have moved that so much there. It's got to pull out the 6 marker now. That's going to give me. I need to use the equation there, payback time equals actual cost over saving. So I got, it costs 2,800 quid, and I'm saving £140 a year. You could do this as a numeracy question anyway. If you like your problem solving, you could probably work that out. But it's going to be, how many times is 140 going to 2,800? And it's going to be 20 times, so 20 years there. I nearly wrote years, and I realised it's already in the heading. State why the householder should install cavity wall insulation instead of underfloor insulation, even though they cost the same. Well, they cost the same, but there's a much quicker payback for cavity wall, because you save double. So you're only saving £80 a year for that, and you're saving £160 a year for that. And also, if you look at the diagram, whatever I've done with the diagram here, walls lose 25% of the heat, whereas what was the other thing? It was underfloor insulation only loses 18%. So I'm going to go for the biggest loss of heat, and I'm going to try and reduce that. But it's only worth 1 mark, so any of those would be sufficient. Now I'm going to clean this up slightly, and I'm going to zoom out again, and I'm going to bring question 5 up. Okay, a lot of information here, so I'm just going to glance to this information. I know I've circled some information here, but I didn't do that until later on. So I've gone to question A, use some of the keywords. This was the easy bit, because heat energy passes along the copper bar by conduction. Conduction in solids, causing the wax to melt. The bar gives out energy in all directions by radiation. It emits heat, so it radiates. Energy moves from the hot to the cold end of the bar. So the only one we didn't use is convection, which is in fluids, gases and liquids. Then you've got a nice little graph, and we're going to do some, we're going to use this graph to get these missing values. So when the distance is 8, you can see I've drawn up the time is going to be 46. And when the distance is 10, I've done it in blue, it's going to be 70. How long did it take for the drawing pin C to fall from the copper bar? I've got to go back to my original one here now. You'd be tempted to use a ruler here to measure the distance from this end to C and then convert it, but don't do that, because this is not to scale, and I tried to do that and it confused me. I think what it's saying is that distance from there to there is about 2 centimeters, look, okay? And you've got to estimate now, because the distance between each pin is 2 centimeters. So I've got 2, 4, 6. It's got 6 centimeters in total. So when it's at 6, there it is 30 seconds. And that's where I've got that from. And the last bit of this question then, the experiment is repeated with a steel bar. State 2 ways of making the experiment fair. Let's move this bump here. You could have any of these. They need to be the same, and then I've put same thickness, same mass of drawing pins, the same flame and temperature of the flame, same type of wax, and the same distance between the pins I've tagged on the end there. But you only need 2 of those. Use the information below to explain why the results would be different if steel bar was used. So I got the rate of conduction in a copper is 212 units, and I got rate of conduction in steel bar is only 26 units. It's because steel is a poor conductor of heat, so the rate of conduction is going to be slower. And we hopefully will get time to do that experiment. Okay, last question. Question 6 for your homework, and then you're done. The diagram represents a section through part of a building, and the cavity wall is filled with polystyrene foam to reduce heat loss. State 2 other ways of reducing heat loss from buildings, where you can have loft insulation, you can have double glazing, you can have draft excluders, you can have underfloor heating by the look of it. Explain how heat loss via conduction or by conduction through the wall is reduced by the foam. Foam is a poor conductor of heat, and it's going to trap pockets of warm air. And that's going to prevent movement of these particles from warm air for this last question there. And I think we're done. Excellent job. Happy Easter.